All right, good morning, everyone. So today we have a few different activities planned. The first one is going to be to finish our intro to our exercise. Then we're going to talk about reproducible tools for data for science reproducibility. And then we'll get into our second exercise, our second coding exercise, which is going to be around data wrangling. All right, so let's go ahead and so you're seeing the folder that I have on my side for the course. I did ask you to download the repo this morning. I pushed some new files there that we're going to be using on the second part of the class today. If you have not done that yet, don't worry, you're going to have a little bit of time to do it in between exercises as we move along today. And so you should be seeing something like this, where we have our 01 intro that we started last class. If you want to go inside of this folder, double click on it, you should be seeing that intro to our partial that we were working on. We almost got to the end of it. So we're going to finish that exercise today. So what I'm going to do from my side, let's see, I don't think I have any RStudio windows open right now. So if I just double click this script, it should launch an RStudio window. And it should pull up that for us. Let's see. Yeah, I think we stopped right here. All right, so I guess we're going to talk more about this in the next exercise, but basically this is the only time that I'm going to ask you to launch RStudio by clicking in a script first, like we're doing here. And this is just before we learn some new improved tools. And when we get to that point, I will never ask you to launch RStudio by clicking a script file. We're actually going to use projects and navigate that through projects, which right now we're not using, and you may not know what I'm talking about yet, so don't worry, but that's kind of the plan. All right, so we stopped here, I believe, right? So if in my case, my environment is empty, as it should be based on the settings we changed last class. And to make sure we can continue the exercise where we stopped, I'm basically going to have to rerun a few things. So let's see here. We're going to have to load Tibble. So this library Tibble here, you do not have to install it. Remember, we just install once or maybe twice to update. But after that, we just load using the library function. So make sure you run the library Tibble. We need to create this object again that we called intro. So make sure you go ahead and run that. It should appear in your environment. And really, I think, oh, and then we have to load ggplot2, the package. So make sure you also run that line of code. And here's where we stopped, right? So we were, if you remember, we talked about, we first used words and just reasoning to decide of our intro data set, which I'm going to print below, right? So we have here name, height, and favorite crop of 5 students. So we talked about, even before we got to coding, which I think, and if you're not used to coding or are in general, I would say this is a really good class for you to exercise, like developing the idea of what you want to do, even before you talk about coding itself or functions or maybe packages. But just like as long as you can develop that workflow in your head, then you translate that to code, and then it's independent of what language you use. So we kind of started with on this approach, right? We thought, okay, we have these columns. What do we want to put on X? What do we want to put on Y? And then we saw how to do that using ggplot. And then we decided to plot as a point. So if you go ahead, this I think we stopped right here. So you should have this piece of code here. If you just run that, we should see a plot to the side where we were just talking about it briefly, that we have the student's name on the x-axis, we have student heights on the y-axis, and then we are showing this data as points. It could have been a bar. I don't remember if it was in this class that somebody proposed to use a bar. We could have used a bar as well. I decided to show as a point, but it could have been a bar. It could have been even, I mean, it could have been a line, even though a line is not the best geometry to show this type of data. Normally, we would think of lines when you have some time variable on your x-axis where things progress over time. So it wouldn't really make super sense to connect, you know, Ali, Charishma, Poli, Umar, and Usman with a line here, but I guess you could if you wanted. All right, so this is one of the places that, well, this is where we stopped. And one thing that I want to show you here is, so in ggplot, we can customize what you're seeing. Everything you're seeing here can be customizable to whatever you want, from the color of the points to the background of the plot to the color of the lines to the color and font and size of the text. Everything here is customizable. And as you further develop your skills using ggplot, you're going to probably learn how to do those things. I want to show you some initial customization options to begin with. All right, so let's say, so the default, we're seeing here the default options that ggplot gives us. So it's giving this gray background. So every time you see a plot like this, it is most likely a product of ggplot because that's the default theme that ggplot uses, at least for the plot itself. And then on the points, we did not assign a color to it. So they're just coming out as round, as circles, and black. That's the default as well. So let's start changing some of these defaults here. So one of them, you know, let's say if I wanted to change the color of all points to something different, right? So one way we could do that is we could come here inside of geonPoint. It has a whole bunch of customization arguments. One of them is called color. So if I say color equals to, and then you open and close quotation marks, we can type here either the name of a color, or if you've been working with colors in the past, you have probably used the hex code of a color. You could also use the hex code if you have that. So let's say you want to be UGA proud, you want to use the red that's specifically to UGA, not just any red. You would go on the UGA website, ask for what is the hex of the red of the UGA colors. You're going to get that specific red that you can put here and use that. Hex code is just a code that, I mean, it's a alphanumerical code of, I think, 6 digits that represents different colors. But to be very simple here, let's say I just wanted to change to red, to a simple red, not a UGA red. If you just type the name of the color, if that name exists within our colors, it will actually change the name of the word with the color that you just specified. So, you know, I mean, some names are very, very common, right? So, I mean, white, black, green, things like that works really easily off the bat. But, you know, if you type UGA red, it does not, of course, it does not have a color like that in R. So let's just keep red and let's just run this piece of code. So once you run it and you look into your plots window here on the right, you notice that the points became red, which makes sense. That's what we asked for. Now, one very powerful thing that ggplot has is whenever you want to map a aesthetics of your plot to a variable. So let's say we talked about, I don't know if you remember, but we talked about on the intro, we have 3 variables, right? So we have name, height, and favorite crop. So we put name on X, height on Y, and then we said, how can we bring favorite crop into this plot? There were a few different opinions on how we could do that. And then somebody said, well, maybe we can color the points according to that favorite crop, right? So maybe everybody that said grape gets a color, maize gets a different color, and so on. So whenever, again, let me say that again. Whenever you want to map an aesthetics of your plot to a variable and the levels of that variable, ggplot has a very convenient way of doing that. So what I want to ask you to do, maybe we can just like copy this piece of code and paste under customizing, just so you keep both for comparison. And then on the version that you pasted, you can just delete that color equals red. Now here, whenever we want to map a variable to an aesthetics, we need to do that inside the function AES, which stands for aesthetics, right? We saw that function at the ggplot level already, but I want to change that at the geom point in this case. So if we type AES, we're going to say color equals 2, and then what is the column in the data set that we want to map this to? That is fav crop for favorite crop, right? So if you just type color equals favorite crop and you run it, look what ggplot does for us. So it knows the data, right? We're seeing what the data is right there. And then every time we're using AES, we have to use column names inside of the data. So it went into that data, into the column favorite crop. It looked for all the specific levels and different options that that column had, and it assigned a color to each one of those. In this case here, all the answers we got were different crops, but let's say if two people said the same crop, then they would have, like, both of their dots would be colored the same, as you would imagine. So ggplot does that for us. It looks into the column, it looks into the levels it has, it creates a legend for us, assigns colors to them, all off the bat, just because you said color equals favorite crop inside AES. Okay? Now, something that if you're new to ggplot, you may get confused in the beginning is, what if I say color equals red inside of AES? What happens? Let's try. It basically, it assigned a red color, but it's not really our red color. I don't know if you can tell. But basically what it did is just assign the same color to everything and created a legend. This is not what we want. What I'm trying to demonstrate here is, if you want to treat everything the same, so every point's gonna get the same color, the same shape, the same size, same transparency, whatever it is, if it is all the same, it needs to be specified outside the AES, like we did above. However, if you want to map some aesthetics, could be color, fill, transparency, size, there are some others, to a variable, then it has to be inside AES, and you have to call the variable, the column name, and not just color equals red, right? So let's just go back to that. All right. Any thoughts or questions about this?
Dr. Bastos, can you hear me?
Yes, I can hear you.
Yes, so I made a mistake, which actually I think can help the class. So initially I added the favorite crop in quotation marks, and that also ended up giving me the same color for everything. And when I removed the quotation marks, uh, in color is equal to favorite crop, then I got a legend and different colors.
Okay, so that was Umar, right?
Yes.
Yes, thanks, Umar. All right, so what Umar is saying is, if you put quotation marks on the column name, then you get just one color as well. So it is a difference in behavior, right? So if you want to specify a fixed value, it has to be outside AES, and in this case, the color name has to be in quotation marks. Otherwise, so let's say if I come back to this example, and if I just say red, R is going to think that this is an object and is going to try to look for that object, and it does not exist, right? So that's why it has to be quotation marks. But then if you're giving a variable name inside of AES, it does not contain quotation marks. Thanks, Umar, for sharing that. Awesome. All right, so I want to show you, again, there's many things in this plot that we could customize and make it publication ready. We're going to learn more about those as we evolve in the class, but a couple easy, quick ways you can customize things is, one, to change the color scale or the color scheme that you're using. This is the default that RStudio uses. We can change that. The other option is also to change the theme that ggplot is using. So the theme that it uses by default is called theme gray. It is what we're seeing here. And I want to show you quickly here a few ways that we can change those two components of the plots. So let's say, I don't know, and if we do, you don't have to say if you don't want, but in the past, I've had students that were colorblind. And there are some color scales here that are not colorblind safe or friendly. So on my teaching, I like to show, to introduce the topic of color blindness, and then always make sure that we're using inclusive colors, that the colorblind, people that have color blindness of any sort would not have issues looking into. So let's change that first. I want to change this color scale, which I don't think it is colorblind safe. So let's add a plus. Remember that ggplot is incremental, right? So we add pluses at the end of the line, we break the line, and then we keep coding. So one way, because we changed the aesthetics color, there is going to be a set of functions that we can start typing scale with me. So scale underscore, and then if you just stop there for a moment and you look at the options that is recommending us, alpha is another word for transparency. So if we were changing transparency, we would actually refer to it as alpha. So we see scale alpha, scale color, scale fill, scale line width, radius shape. There's a lot of different things that we can change. So we set what we want to do with that aesthetics at the AES level, but then we can customize it using the scale underscore functions. Here, because we're changing the color, then we're using scale color. So you type color, and then you can see the options you have. There's a handful of options here. There are more in different packages, like ggthemes is a package I think you all installed that extends this list to include even more. And then ggplot2 has a Verities set of color scales. There's a Verities B, C, and D. These are for B's for bin data, C's for continuous data, and D's for discrete data. Our data that we want to change the color is going to be discrete, right? Because favorite crop is a character variable, so it is a discrete variable here. And if you're not aware, Viridi is a very popular set of color scales that are colorblind safe or colorblind friendly. So I always recommend you use something like that to make sure your plots are inclusive. All right, so if we just run that, you're going to notice that now the color of the points changed to this yellow to dark purple scale. This is a typical Verities color scale. You're probably going to see this a lot in different plots in different publications. So this is an easy way to change the color scale. There are many options that I showed you, and I'm going to leave it that for now, but let's use Verities in this case. And then another easy way to change the way this plot looks is by changing the theme of the plot. So if you just add a plus here, let's hit return. And if you start typing theme underscore, you're going to see a whole bunch of options here that you can change. The default is theme gray. So this, if you select theme gray, is going to be the same. There are some very different ones here, and these can also be extended by installing some other packages that offer different themes. But I want to show you maybe a couple of my favorites and a very different one. So I normally use either light. So let's try light. So it's a very light, I guess, theme. I want to show you minimal as well. I think it's another good one that I've seen used a lot. I want to show you one that's different. That is the theme dark. So this, if you're a fan of dark themes on your plots, then this is one that you can use. So really, there's a lot of options here you can change. I'm going to leave the color Verities, D, and theme dark for now. And then we're going to stop here as far as customize. Again, we could have customized every single thing about this plot, but this is not a ggplot customization full-blown class. It's just a few examples I wanted to give you. All right, so let's say that this is your project that's in, I don't know, maybe you're making a plot for a presentation, for a poster, for a paper. You need to export this. You need to get this outside of R and into your file system so you can embed into something else, a Word file perhaps. So how would we go about exporting this? So ggplot has a function called ggsave. You can type that. What it does by default is it takes the last printed plot that you have and exports that. If you don't like that, you can specify, let's say you could assign this plot to an object and then call that object specifically here. You can do that. It's probably good practice. I normally don't do it because I always have my digisaves following the code of the plot that I have right above. So I just keep it digisave. And then we're just gonna, if you open and close quotation marks here, you can specify the path. And with paths at the end, we just give the file name and extension. So right now, if you hit tab, I just want to show you what happens. It pops up the intro to our partial.r file. That's because it is basically pulling this fold or this path to us. And since there's only one file, if you hit tab, it's just populating with the name of that file. So you can just delete all that. And at this point, if I want to save this file at this level on my folder structure, I'm just going to give it a name. I want to call it plot1. And then here you give the extension. So I normally save as .png. It could be PDF, it could be JPEG, it could be other formats, it could be TIFF. If you ask for the help on this digisave function, you get all the options of how you can export this if you have a specific file type that you need to use for a paper, for example. So I'm just want to export as PNG. If you run this digisave, and then if you come here on the Files tab, so you may be still on the Plots tab. If you come to the Files, you should be seeing now this plot1.png. If you click on that, it should pop up this plot for you, right? So again, this is not the most or the sharpest plot. I would make a lot of changes to it if I were to publish something like this, but it's just a good point for us to be thinking about. Okay, so we have an assignment that I think we can actually just take like 5 minutes. I think it's a very easy assignment, as you can see. What I'm asking you is for you to play with two functions on the code that we just created. So I want you to play with the scale function and with the theme function. Use different ones from what we're creating in class. So I do not want you to use color Reproducibility or theme dark. Use different color scale, use a different theme, play around with them, see which one you like. Choose one set of theme, one set of color scale, and then export that plot using digisave. When you do export, I want you to name like plot underscore A1 underscore last name. So I would name something like plot A1 Bastos. And then I want you to, once you have exported, it's going to be in our file system. I want you then to just bring this to GitHub. I'm going to create an issue called assignment 1. I want you to go there and paste and basically embed your plot there. So again, it's incredible that I say this every time, and I always get students that lose points. If you create a plot that has scale reduce D or theme dark, you're losing points. Easy. Do not use those. I want you to play around and find different ones for your plot. It's okay if you all share some similarities when you export, but as long as you don't use the ones we use in class, you're gonna get full points for this. So while you're all working on that, I'm gonna go on our GitHub repo and I'm gonna create that issue so you can submit your plots. I created for you. Oh, thanks. So Arminder already created. Is it called assignment 1? Yeah. Okay, thanks, Arminder. So Arminder already created the issue on our repo. So if we do github.com, Yohan Bastos 2025 underscore DSA. Oh, I missed something. There's going to be a new issue here with assignment 1. So just make sure you paste your figure here. So just add that here and then submit your response. And if anyone has any questions or issues, let me know. We can talk about it. while you're working on it, I just want to give you one tip here. Um, as you're going to notice, you see your files here, but you cannot really drag and drop or click, or I mean, you can click on them to open, but you cannot drag and drop them in or out of this folder through RStudio. There is this engine symbol here you can click, and at least on a Mac, these are the options that I see. And one of them is show folder in new window. If you click on that, it's going to show this folder on your operating system, and then you can, drag and drop and move things around as you wish. So that whenever you're exporting that or pasting that to GitHub, you can do this. So click on that blue engine symbol, show folder in your window, and then you can just do that. Gonna put 3 minutes here on the timer.
Excuse me, Dr. Bestros.
Mhm.
Uh, is my plot in is looking weird to you as well in the GitHub?
Let me
It
check.
look My username is UM004.
Yeah, it looks a little bit weird. Yeah. I mean that's okay. You're not gonna miss points, but did you change the height and width, perhaps?
My windows are not like equally proportional at the moment because I'm using one screen, so maybe that's why.
So if you use DigiSave, that shouldn't matter.
Yeah, I
Um,
use DigiSave.
hmm, interesting. So let me see. We still have maybe a little bit of 35 seconds. I can show one of the features of DigiSave. So if you something that you're all gonna notice, especially as we start using a different file type other than our scripts, which is gonna happen today. Um, Sometimes the way that you see so if you go, I mean, even here, I think it makes sense, right? So if I'm looking at my plot right now, it is squeezed. And if I increase the size of this window, it changes the dimensions, right? this is just the way you're seeing in our studio, it does not reflect how it will look like once you export. If you ever want to make sure that you're getting the right dimensions of your plots, you have to make sure that you export with a given dimension and then check the exported file and not this window here in R. As you saw, this window is going to change the way the plot looks as you resize the window. Uh, so it kind of fools you if you're based off of that. Here, DigiSave has it has many arguments, but what a couple of them is width. So I normally use a width of 6. This is in inches and a height of 4. We did not change this, so we just used the default, which I think is 7 by 7, or no, actually, here's the default, 5.78 by 5.14 inches. If you're gonna change that default, you can just use the width and height arguments, and then check on your exported file, not on the plots window, but check on the exported file that you do. You're gonna see that reflected on the exported file. So I'm not sure, Omar, maybe on your computer for some reason, maybe your default size is different. But if you wanted to change that, this is how you would change it. But you don't have to worry about it. It's okay the way you export it.
So I dragged the windows, I changed the proportion, I saved it again, and the resolution it changed. First it was 2 by 5, and when I dragged the window towards left, then it's did you saved it at 6 by 5.
Okay, interesting. Maybe that's a new behavior. Um,
So dragging did change.
so dragging is changing. Okay, it didn't used to, so that's good that you brought it up. Well, I guess if it is changing anyways, depending on how you resize the window, I would recommend you do not use the resizing option like manually, but instead find a combination of width and height that works for you, and then just keep using that on the code as that is reproducible, right? You don't want to find yourself having to have a mark on your screen to say where your window should be for you to get a certain type of resolution to be consistent across plots. So just use the code for that, and then that ensures you're reproducible for future plots. Thanks, Omar. All right, so this is the end of this exercise. If you were not able to submit your assignments, I mean, you can do it until the end of today. It does not take a lot of time as you noticed, but if you had issues of some sort, maybe that kept you from submitting, you have until the end of today to do that. Please go ahead and save your script. So you save everything you've done. So click on that save button. You know it is saved if your file name here changes to, in my case, changes to white. All right, so this wraps up our intro to R. Before we move on, I would just want to open the floor to see if anyone has any questions or thoughts. Right. I don't hear any, so I'm going to keep moving. I'm just going to go ahead and close this RStudio window. And I guess before I do that, I just want to call your attention to one thing, which is going to be different as we move forward. Right now, you notice that we have a project none. At least that's how it should be, I guess, at this point, if you're following the class and the pace we're following. We don't have RStudio projects yet. So I just wanted to remind you of that as that's going to change in the next exercise. All right, if you just want to go ahead and close this, and then we're gonna go to the website. Remember, if you don't have it yet bookmarked, I highly recommend you bookmark it because we're gonna be using it a lot. And I have a new set of slides here that we're gonna go through. So this link should be active for you. If you want to open that on a second window, you can do that. And if you remember, we talked about in the first class, if you want to export this as a PDF so you can take notes, you push the E button of your keyboard, and this makes continuous scroll view. And then you can just go on File, Print, or Export as PDF. All right, so This is a presentation I put together to talk about some concepts around reproducibility. And I want to tell you basically my personal path on this and some of the things that some of the issues I faced and what type of tools and software I was able to learn and use to overcome those problems. So let's talk about that. All right, so to begin with, what is reproducibility? We talked a little bit about this on the previous class, but research is reproducible when others can reproduce the results of a scientific study, given only the original data, code, and documentation. So this is one of the concepts of reproducibility. So this applies to other people that may want to reproduce your work, right? So maybe you publish a paper where you make your code and data available. Other people should be able to download that, and as long as they have the same software that you used, they should be able to reproduce your work. But also your future self, right? So think about, you may want to rerun an analysis that you did for a poster. You may want to rerun that for a paper, and maybe you want to improve upon it. So reproducibility is not just to other people, but to your versions of you, both in the future, but also in the past. How many times, I don't know if you had these moments, but I've certainly had these moments when I'm revisiting a project, a code, and I think, my gosh, I wish that I had documented this better. I had explained why I did this. So now when I have to redo it, I remember my decision making, right? So your future self is also part of that reproducibility component. So why bother about this? So basically, this is going to help you to track the how and why of specific decisions and analysis that you're doing. If you are using reproducible science, you're more likely to be able to quickly modify analysis and figures if you need to. And with that, you have increased efficiency. You also have rigor and transparency. If you're thinking, especially if you think about like, okay, I'm going to run this, I'm going to create a script to do a certain analysis. And my goal is when I publish this paper, I want to make this script available as well. If you have that in your mind from the beginning, you put yourself in a more rigorous and transparent mindset. So it really makes you think, okay, does it make sense to use p-value of 0.64 here? Or I'm sorry, 0.064 here, or maybe 0.05, or maybe 0.1, whatever it is, whatever decision you're making, if you're just making perhaps arbitrary decisions, if you're thinking about reproducibility, especially sharing, that puts you in this more rigorous mindset of, okay, I have to make decisions that make sense, that are grounded on principles, so others, will understand and make sense to them as well. Also, this may increase your citations. So if you do publish your paper and then publish your data and publish your code, those are all separate pieces that can be cited separately, that can get you more citations as well than just a paper. And I just want to bring, so there are many studies around this. I'm bringing one here. If you're following this presentation online, this is a link. You can click on it so you can check what I'm saying. But this is a survey done by Nature that assessed 1,600 researchers around this topic of reproducibility. And what it found is that over 70% of those researchers have tried and failed to reproduce another scientist's experiments. Now, just think about it, right? We talk so much about, okay, so I do this study here at UGA, I find something, I find X, and then my partner or my collaborator in a different university does the same protocol, everything the same, and finds a different outcome. There are many potential reasons for that to happen, but one of them is could definitely reduce the 70% if we use reproducible tools. Also, this study found that about half of these researchers failed to reproduce their own experiments. Now think about that. So reproducing your own work, about half of those could not reproduce it. This is an issue, right? Because if we're doing science that is informed something that perhaps at some level of that scientific discovery is going to inform maybe policy, or maybe it's going to help somebody make a better decision, but then we're giving these answers that cannot be reproduced. That's an issue, right? We should aim and target to be more reproducible in our work. Some of the main causes that they identified of this lack of reproducibility were selective reporting. So let's say, well, I ran 3 ANOVAs here, but really only one is telling the story that I want to tell. I'm just going to show that. I'm not going to show the other 2. Or maybe I'm going to remove some data here because it's not helping me with my p-values, or whatever it is, right? Things that should not be done, but are done, unfortunately. Or weak stats. A lot of people, and as you develop your skills, as you start reviewing other papers, you're going to realize that people do a lot of wrong analysis, even on published papers. If you submit a paper that you did an analysis that maybe was not the most correct, and then your reviewers are also not aware about that, they don't know about that analysis, it may get through, and just because it's published doesn't mean it's right, right? So this is something for us to keep in mind as well. And then perhaps even though papers say that they are making code and data available, but maybe it's just upon request. And then if you request, maybe it's even hard to get that. So just that availability of code and data, even when it is supposed to be available, may not be as easily available. And then this all trickles down to this one example that I think I briefly talked about in this class, about the 2006 Duke University cancer research case. This is a link if you want to click on it and read the full story. But in a nutshell, this was a study conducted at Duke University where they were developing an algorithm that could recommend the best treatment for cancer patients from the beginning. My understanding of it is any cancer patient that is going to be treated, there's a series of treatment levels that it's kind of like on a trial and error scenario where they try something. If it works, great. If it doesn't, they try something else and so on until they find what's the best for that person. This algorithm here was basically trying to give that best treatment from the beginning and predict what would be the best treatment from the beginning for each individual patients. So when this came out, it was huge. I mean, a lot of hospitals were starting to use this algorithm to really apply to their patients outside of research, but actually applying to people that were being treated for cancer. And it was like, you know, a big breakthrough in this type of research until another group of scientists asked for the data and the code to try to reproduce that algorithm, to recreate that algorithm again. So this team from Duke provided the code and data. And basically that team, the second team was not able to reproduce the same algorithm. They were getting to a different algorithm, different recommendations. Everything was different. And they were only able to reproduce the same final outcome after making deliberate changes on data and code that should not happen on a reproducible research set. So this is a big problem, right? Especially in this case here, cancer patients. It's a really, really sensitive topic that we want to make sure things are reproducible. Most of us here are working with plants or maybe pathogens or maybe insects or maybe food or not, you know, we don't have cancer patients waiting for our algorithms, but that doesn't make us any less responsible to make sure our research is most reproducible as possible. All right, so I want to talk to you about some of the barriers and the solutions that I found within my own path. This is not an extensive list, right? I'm sure different people go through different things, but this is just some examples I was able to pull from my experience. So number one is file naming and management. So when I started my master's, this is how my file management system looked like. So at the time I was using SAS for my stats. So we see some Excel files, some figures, some script files, all kind of mixed together in one folder. And this is just not really great, right? So everything is mixed. The file names are not very informative, right? So if you look into these file names like 23 daily, 23 grain, I mean, what does that even mean, right? I don't know what variable that is. I don't know really what's in there. I have to open it to be able to understand what's in that file. And this was just the beginning of my first year, right? So the longer you do your projects and your research, the more complex this becomes. And the sooner you create a system that works for you, the better off you're going to be as you develop your program. Hopefully it doesn't look familiar. Hopefully you're already doing a better job than I was doing when I was starting my master's. But if not, I have some suggestions that may help you get there. All right, so the solution for this was principal file naming and project management. Let's talk about that. So what is principal principled file naming. It's just us naming files with intention and making it easier for us and for machines to work with those files. So 3 principles of file naming. The first one being machine readable. We want our files to be machine readable. What does that mean to be machine readable? So we want it to contain key metadata, and we want to separate that information with either a dash or an underscore. So what I'm showing here first is how I initially was naming a file that contained cumulative greenhouse gas fluxes over 2 years. So I changed that to start with the year, so 2013, 2014. What is the variable? And that is cumulative and not daily. Right, so really changing a file name that was very uninformative to something that was right out the bat very informative. Just by reading that, I know what's in there. And this is because we want it to be easy to search and filter and easy to extract metadata. So let's say you work with something that creates thousands of files that follow a certain scheme. So let's say maybe you're working with, bioinformatics or something that just creates a lot of files, and they follow a default standard naming scheme that is useful, right? So let's say in this case that I'm showing you here, if you notice where I separate with underscores, it's basically variables, right? So this first variable is the time variable. I have an underscore, and then I have the variable that I'm measuring, and then I have a dash here. So if you notice what I'm using here is the range of time I'm separating with a dash, and then variables I'm separating with an underscore. So time underscore the variable, and then within the variable I'm specifying it is N2O, a greenhouse gas, and that is cumulative instead of daily. So if we create systems like that, and if you need to extract information from file names, it's easy if you're following a default way of naming those files. The second principle here of file naming is human readable, right? So it should help you to read that file and know what is going on. So it should be a name that provides information on the concept and that follows the slug concept. So here I'm showing you the list of names that I gave initially and how I could change that. So daily 1 CSV is basically the daily emissions of N2O in 2013. And then analysis year 1 QMD is basically the analysis of variance of the nitrous oxide daily from 2013. So you just start changing the name of your files to make it easier for you to know what's in them. Right. And I'm sure, well, I've been there many times. Maybe you haven't if you're more planned than I am. But which set of files would you like to have in front of you if you're working with them at 3 a.m. before a deadline that morning, right? So this really helps you to start becoming more efficient and more organized if you give some thought about this. And then the third principle here of file naming is that it plays well with default ordering. So what do I mean by that? It's useful if you start a name with something numerical. So that could be the dates, the time, maybe the experimental number, or something that's easy to sort by alphabetically and that falls into the order that makes sense to you. If you're using a date, we prefer to use this format of year, month, and date. This is the one that's gonna sort the easiest for us. And left pad numbers with 0. What do I mean by that? So sometimes you may be numbering your files, and maybe you use 1, 2, 3, 4, 5, and then you get to 10. And if you do not left pad your numbers before 10, what happens is you have 1, 10, 11, 12, and then you have 2, 3, right? So to avoid that and make sure they follow, we want to left pad numbers with 0. So here I'm giving 3 examples. So N2O daily from specific date here in 2013. The way that I would fix that was to begin with the date, so year, month, date, and then the variable. And then notice here on the second one, this happened on October, and this happened in January, right? So this is how it would sort for me if I were to change the date to the beginning. But once you use the year, month, and date, and you left pad your months, then it sorts correctly. So with October after 2 here, not after 01. All right, and then so that's us talking about file naming, right? But now we need to organize those files into folders. And then I have a few suggestions of how we can do that. So we want to go from something like this, where you have all of your files mixed and you don't really have a system, to something like this, where you separate each file type by a different container or folder, as we're going to see. So I'm showing here one example of one of my analysis that I was doing for a project back in 2019, where at least the minimum 3 subfolders that I would encourage you to use is one for code, one for data, one for output. That's the minimum. That's what I always do. You may have one here that's for writing, for reporting, or maybe resources or some other folders that may come into play here. I always have at least data, code, and outputs. As you would imagine, your code files go inside of a code folder, your data files go into your data folder, and then any output that you create, it could be a figure, it could be a table, goes into your output folder. So you start organizing things like that. And then if you're using RStudio, as we're going to be using in this class, we're going to use RStudio projects. So here, we're going to see what that is when we start coding, actually. But you know that these files are, this folder 2019 JD, which is my project, has an RStudio project because it has this .rproj icon or .rproj file and this icon inside this folder. That's going to be very, very helpful for us in different ways that we're going to see in a moment here. All right, so barrier number 2 that at least I ran into was proprietary point and click software. So when I started my master's, I was using many point and click proprietary software. So using Excel for data organization, manipulation, even data plotting, which I don't do anymore. I guess these days I just use really Excel, but for data entry, I don't do any analysis in Excel anymore. Mostly for reproducibility purposes. I was using SAS for stats. Just at least here in Athens that I can see your hands and faces. Has anyone learned how to use SAS? Is that still something taught? Can you raise your hand if you are, or okay, so maybe a few people here use SAS. I have a feeling SAS is gonna, at some point this lecture, are gonna have to change SAS for something else because I don't think it's gonna be taught for too much longer. But still, SAS is a statistical software that was the default software that we would learn stats with in universities. So that was my case. I was using Sigma plot for plots. And then I do a lot of geospatial analysis. So I was using ArcGIS for maps. All of these are proprietary software that at the time, I mean, I really did not see a problem with that. But the problem with using proprietary software with reproducibility is that you're imposing a paywall, right? So yes, my work may be reproducible, but you have to pay and have these software to do it. So, the way that I decided to approach this and what I recommend is to use open source free software whenever possible. So proprietary is one piece of that, and then we have point and click as being the other piece of that, right? So point and click software, it is very prone to human error. And we're normally not very good at documenting what we're doing, right? And because point and click does not create documentation for you, and you're not documenting yourself, then it basically becomes very hard to reproduce something that you're doing with point and click software, right? So maybe just to put us on a thinking mode, think about the last time that you organized data in Excel, right? So we brought this data in and think about all the potential things you did to it. Maybe you created new columns, maybe you deleted some rows, maybe you shifted some data around, whatever it is, right? That can be very key. This is one of the issues that happened with the Duke University problem, is they were doing some changes in the data that maybe, an undergrad intern was doing some changes and then they did not let the other people know. And then the other people thought there was something that it wasn't. And it, in the end, just becomes very unreproducible to do something by point and click, right? It's hard for you to say, take this raw data, move these columns around, create this new one, filter out these values. Even though we're doing that, we're not really used to writing down everything we're doing with point and click. So then it becomes unreproducible. Or maybe if when you were creating a complicated figure, if you were doing that on a point and click software, think of all the little things you moved around and you did by hand. How can that be reproducible by even your future self? It can be difficult, right? So a solution for that is free programming languages or just free open source software in general, right? So instead of Excel, I started using more CSV, even though it opens on Excel if I double click on it, but if I didn't have Excel, I would still be able to access it. So CSV, comma separated value, is another type of file that we use to store tabular data. Instead of SAS, you can use R, Python, Julia, Perl, other languages. Instead of Sigma plot, you can use also the same options. Instead of ArcGIS, you can use R, Python, or perhaps QGIS, which is a point and click software, but it is open source. So there are options out there. I know, some areas, maybe there is not an open source free software that you can use. Perhaps that's an option or that's an opportunity for you if you're into these things to create an R package or maybe a Python library that can do that instead. All right, and also code is documentation. As you're going to start seeing, I'm going to show you a very easy example here, but I'm starting off with a data frame, and I'm printing that here. It has 5 rows, very simple. It has a column called plots and a column called N2O underscore ppm, which is just the concentration of nitrous oxide in ppm. Very simple, right? So let's say I wanted to do a few things with this data. So I wanted to first, so starting with the data on the row 1 there, I wanted to filter and to just keep values where the concentration was above 1, because for some reason, maybe in my discipline, values below 1, and on this equipment I'm using, let's say they're below detection limit, so maybe I don't want to keep them because they may be erroneous. So I'm filtering them out, and then I'm creating a new column that I'm calling N2O ppb, that is just transforming ppm to ppb by that equation. And then finally, I'm just selecting the columns plot and N2O ppb, and this is the outcome. Right? So imagine how many times you've done something similar in Excel, but it was not reproduced. How did you take note of what you were doing? Probably not. And if you're doing this with code in any language, the code itself is documentation, right? It is telling you what you're doing each step. So if you ever have to know what was your starting data frame and how you ended up with the final data frame of 3 rows, you know what happened in between because the code is the documentation for that. And then you can also expand your documentation by adding comments, like I'm doing here, right? So you're adding comments to make sure it's very clear what's going on. All right, so the third barrier here is static programming and environment. This may not be as much of a barrier, but maybe something that we can improve upon. So I'm showing you here a static script. Basically what we're using, so we were using a .r file, a R script file up until now, where we have basically the code, and then we may add some comments here, but it has to be preceded by the pound sign. So R does not interpret it. And then one of the improvements of this is using a integrated development environment, an IDE like RStudio. So that we're already doing that, so we're already learning how to do that instead of just using R by itself, which I don't think many people do it anymore. But using an IDE helps to make it easier, make your life easier when you're running any analysis. And then also using literate programming. What is that? So literate programming is this concept where we mix code, output, and narrative on the same file. Some examples of doing that, if you're using Python, you may have used Jupyter and Jupyter Notebooks. That is one way of doing this. We're going to be, on the next exercise, we're going to use R Markdown. And then from that point on, we're going to use Quarto. When we get there, I'll explain to you why we're using both and some of the differences. But these are some options for literate programming. Another thing here that's important for reproducibility is keeping track of changes. And this is something that in this class we're going to use a lot. So I just want to set the problem first here. So, have you ever wished that you could go back in time with your work? So you maybe think about the situation here. You spent the whole week working on an analysis, and then at the end of that week, you found out that it didn't work as expected, or you really got stuck with multiple bugs. And you think, man, I just wish I could like go back in time and go back to Monday where I started this and just reset, restart from that point on. Or maybe another situation is at some point your script had an important piece of code that you were using, it was useful, and then you decided to remove that because you thought you were not going to use it anymore. And then maybe a few months after you realize, I really wish I had that piece of code again, and I deleted, I didn't keep it, and now that would come in handy. So wouldn't it be nice, useful, sometimes perhaps graduate school life-saving if you could simply go back in time and start fresh from the last working version of your code? Especially again, if you have not worked with code as much, this is what we're going to learn in this class. So, you're gonna quickly realize that code develops fast. You develop code fast, and sometimes it would be just nice to be able to go back. So a solution for this is using version control. So version control, you can think about it as track changes, but on any file type. And this is in our case especially, is very useful for script files. So .r, .rmd for R Markdown, QMD for Quarto files, where you can really keep track of how you're developing that script and how you're changing things over time. So the idea here is that as your code grows and develops, you take snapshots in time that save the state of that file on that date. And then, so you do some work, you take a snapshot. You do some work, you take the next snapshot. You do more work, you take the next snapshot. So you're basically tagging yourself over time with versions that you can go back to and revert to if you need it, in case you have some issues in the future. And this also helps to connect your current self with your past self. So, you can go back and think, what were I thinking when I decided on doing this specific analysis, or maybe this specific decision in my workflow? Locally, and when I say locally, I mean in your own computer, we're going to be using Git for this. So Git is one of the software that do version control. It's one of the most popular ones used for this purpose. However, one issue or one barrier here is that Git works locally on your computer. So then we know one barrier for reproducibility, especially if you want somebody else to reproduce your work, is somebody else has to have access to your work. So we have to make that available so people can see it. So reproducibility, the full spectrum of that requires sharing. So Git again works locally, right? So it's very powerful on its own, but it only acts locally in your computer. And it becomes even more powerful when we can have all the features that Git has, but working online. And also when we work online using Git features, it's really great for collaboration beyond just sharing. And I'm going to show you an example here of how that was working. So a solution for this is open data and code, where GitHub is going to be the main component of that. So GitHub is an online centralized platform that combines Git, collaborative tools, and cloud storage, all free. And one issue that I've had in the past, and I know you're going to run into as well, is okay. So I wanna be reproducible. I want to use RR Studio. I want to use Quarto or R Markdown. I want to use Git to keep track of my changes, and I want to use GitHub as well. However, I don't want to let everyone to be able to see my data on GitHub before I publish, for example. It's a great example here, right? So whenever we're creating GitHub repos, we can choose if we want to make it public, so anyone that searches for it can find, or if we want to make it private, which means only you and people you give the right to can find it on GitHub. So that's a great feature right there. So I want to show you here a very quick demo of how I've used in the past and still use to this day to GitHub to track my work, but also to collaborate with others. So I'm going to show you here one GitHub repo that was created to conduct an entire analytical workflow of a manuscript among two collaborators. And both collaborators, in this case, myself and my collaborator, we had local versions of on our computers that we were using Git to keep track of, but then we use GitHub as the centralized hub, right? So I did some changes to a script. I would save that on my computer. I use Git to take a snapshot of that, and I would send those changes to GitHub. And then I will tell my collaborator, hey, I just made some changes, just created a new plot, just made a new analysis. Make sure you bring those changes from GitHub to your computer so you can see them on your side. So she would do that, and then she would be able to see what I did. In the same way, whenever she did something, she would do locally, send to GitHub. I will get a copy of that and be able to see directly what she has done. So this is a link I don't think is going to open on your side because I think it's still a private repository, but I want to show you on my side. So if you see here, this is GitHub again. I have a data markdown, which is another way of calling code, at least on my workflows. So a data, code, output, and resources. One cool thing is that you can, so a commit is every time you take a snapshot, you do a commit. And I want to show you here, one of the cool features of Git and GitHub is that you can see a history of the commits. So if I click here, I see that the last commit was November 15th of 2021, when about the time when we submitted this paper for publication. We can see I was doing something here on the files. And if I click, so what I said when I sent this commit was trying to find issues on number of samples, just reran IDW, about to save new results to file. If I click here on this commit, it's going to show me exactly what files were changed and what was done. So if it is a red, it's because I deleted. If it's green, it's because I added. So you can really see line by line what was changed on different files, where, how, and when, very easily to keep track of. I want to come back here on my code. I want to show you, so this is me making changes. This is my collaborator making changes. So we were doing changes separately in our computers and then using GitHub as the point of conversion of our work. And something that I was telling you earlier is, so if we go back here to code, if I look here, this is how the repo looked like the last time somebody made a change. If I come on my commit history and if I say, you know what, I wish I could go back in time and maybe see how this repository started, like what was the first commit and how it looked like. So if I go to my first commit, oops, wrong button. So if I go to my first commit and I browse my repository at that point, this is how it looked like in my folder, right? So I'm showing you the most recent and the oldest version of this repo, and there's 48 snapshots of time in between them, right? So you can really go back and see what happened when something was created. If you want to revert back to a certain version, you can do that as well. So this is the power of GitHub. We're going to be using this a lot in this class. Just wanted to show you one example of that. Where's my? Huh, I don't know where my lecture is now. Oh, I think it was actually on the. Yeah, all right. Okay. So our next barrier here is what if software versions change, right? So things change. To begin with, at the highest level, your computer operating system gets updated, R gets updated, RStudio gets updated, packages get updated, and all this can cause some issues, right? So even if we're working off of the same GitHub repository, if our local software versions may differ, this can cause discrepancies that may impact reproducibility. And I'm sure it's going to happen in this class. I'm sure that, I'm going to have a package version that may be older than the version that you just installed, or maybe you have an older version than what I have. And those discrepancies are going to come into place. One solution for this is containerization. So what does this mean? Is to avoid the discrepancy at the level of software, we can use containers. So containers are going to keep track of all software that's being used and what is their versions in a given project. And whenever you copy that project from GitHub, for example, or you make a clone of that project is going to ship with a file that's going to tell your computer what are the versions of software that should be used to make sure this is fully reproducible. So this ensure, again, that the project is reproducible not only for collaborators, but your future self. Because perhaps, today you may install ggplot2 and you may have that version that works beautifully on your plots. And then in a couple months, maybe ggplot2, pushes a new update that breaks your code. So now what used to work doesn't work anymore. You can revert back to those versions very easily if you're using containers for that. One example of containers is to use Docker. This is one very popular software. R has a package that Docker works across not just R, but across your whole computer to keep track of software versions. R itself has a package called renv that helps you to do that as well, but specifically with R related files. So really, in a nutshell here, reproducible science is about using sensible file names, organizing files in sensible subfolders, using free programming language software, using literary programming tools, using version control locally like Git, using distributed version control like GitHub so you can share and collaborate, using containers, and other things, right? So if you create custom functions for you, that is part of reproducibility. If you create iteration workflows, which we're going to learn about, that is also part of it. If you do code peer review, that can also be part of it. So there's many pieces here that can help us be more reproducible with our research. And then, this is just perhaps when I created this presentation initially, I was still preparing this course that you're taking now, but now I guess doesn't apply as much. But I just wanted to let you know that all my presentations are made with Quarto. So my presentations are reproducible because you can get access to the code that created them on GitHub. You can find more info about everything that we're doing in my website, which, by the way, was also made with Quarto. So even my website is reproducible if you were to get the full code for it. As you know, you can find more stats and programming materials on my website. And then this class here is really where we are going through a lot of these concepts. All right, so this is what I had for this presentation. I think we have a little bit of time to jump to our next exercise, or at least to start it. But before we do that, I just want to open the floor to see if anyone has any questions.
Dr. Bestos,
Yes.
so the PDF of the slides, if we make a PDF, a lot of the pictures, those are missing in the PDF. So I don't know, is there any solution to that?
Let me see here. I'm just checking on my side. So for me, they're not missing. I wonder, are you on a Mac or a Windows?
No, I meant that when I make a PDF of
Right.
this slide,
Mhm.
so a lot of the pictures that are in your slides that are missing in the PDF when I make it a PDF. That's
Yeah,
what I meant.
so on my side, they're not missing. So that's why I was asking if you're using a Mac or a Windows, because
Yeah, I tried using both Windows and Mac. It's the same for both operating systems. So.
anyone else tried to export the PDF and was having issues? You had an issue as well? Okay,
Yeah, same here too. Now
same.
that I looked at it, most of the pictures are not showing on the PDF.
Okay, so I'm not sure if I mean, there's something going on between HTML and our personal computers here that I'm not sure, like if it was an issue of the HTML alone, then everybody would have the issue. But it doesn't seem like that's the case. So what I can do is I can export as PDF myself and then share that with everyone. So you have access to that. So you can see all the pictures.
Yeah, that would be great. So what I think is happening, since the photos are stored in your personal computer, I think is fine on your end, but when we are trying to pull it, those are not just getting into the link of the website, I think. But I don't know. Just
Yeah,
uh,
it could be that. Well, I'm gonna create a PDF and then share with you all through the GitHub repo. So I make sure everyone has access to that. Yeah, thanks for bringing that up.
And Dr. Bastos,
Yes.
so anytime we post a repository, do we need to download all the packages, or we can just download like just one folder from the repository?
So when you're downloading things from GitHub, and just to let you all know, that's gonna change maybe in the next couple classes. We're gonna change to actually using GitHub the way that it was supposed to be used and not just downloading manually. But until we get to that point, we're gonna download manually just to not bring a lot of concepts at once. And I think when you're downloading manually, it's gonna be easier if you just download the whole repo, following those instructions of clicking on that green button and then downloading the zip file. I think that's gonna be easier to do. Yeah, so I would recommend doing that. Yeah. All right, so I want to ask if anyone would like to perhaps share a thought here, like if did you identify anything here that maybe clicked to you, like, oh yeah, I can definitely see that I could improve what I'm doing with some of these tips, or did anything resonate with anyone that you'd like to share maybe your thoughts? Yes.
The part of labeling the documents is really helpful. I remember that sometimes for a visitation, you need to go back like a year of your documents to reproduce an experiment that you needed to, because like the paper asks you to do it, or you see that another way to solve it. But if you are not really specific with your like documentation, it's going to be hard and it's going to take a lot of time. And most of the times it's going to be hard to reproduce all the data.
Yeah.
So I feel like labeling is really, really important. And classifying folders. So I think that one.
Nice. And what's her name?
Ruben.
Ruben. Nice. Thanks, Ruben, for sharing. Yeah, so Ruben was, I don't know if online you were able to hear, but Ruben was saying that naming the files and the folders and organizing that way really helps. It seems like he was speaking from an experience of a paper that I think he submitted, and then a reviewer may have asked him to go back and redo something. And if you don't have a system like this in place, it can be very difficult to reproduce something you've done in the past. Thanks, Ruben. Awesome. Anyone else has any quick thoughts around this that you'd like to share?
Yeah, I also have similar experience. Like after starting my PhD, I was writing some paper with my master's manuscript, and then sometimes when I'm looking for a specific file or data, it takes me a while because I didn't name it very well. Sometimes I just save it with the name of the file, the default name, and now it takes me forever to navigate my computer to get to the files. Then I was using JMP in my analysis. So in my master's, I know how to use the JMP very well, but now I'm using R. So anytime I go back to my master's manuscript and I'm trying to do the same thing in JMP, it takes me for some time to remember what I did in JMP. So
Absolutely. Nice. Thanks, Weber. Appreciate that. Awesome. Well, for the interest of time, I think let's do a couple things. One of them is just to ask you to have downloaded the files from GitHub. I think we can work on that exercise on Thursday and start fresh from the beginning. So I don't want to start today and then maybe forget what we've done today. So I want us to start fresh there. And then I have a couple of things to ask you. One of them is simple, another one is it's not as simple, but it's not difficult either. So the first one is I'm gonna take your attendance. We do that through GitHub. So go to our class REPO 2025 DSA. I want to open an issue for attendance. And just to let you know why I use GitHub, so I basically, let me just put here attendance, January 14th. You can just drop me just a word saying that you're here, and that's going to be sufficient. Please make sure you claim your attendance while you're in class, because I may decide to close this issue after class. And if you had not responded, then I'm not going to be able to know if you were here or not. So just make sure you respond while in class. And the reason why I do this on GitHub is because I develop a code that basically pulls this data from GitHub and creates a table of attendance for me that I can then bring into ELC. So that makes my life easier and Amarinder's life easier as well. So he doesn't have to do that manually for us. So please go ahead and do that. And after you've done that, I have a quick quiz. So if you go on ELC, see if it is. Yeah, I'm gonna make it visible right now, but it's quiz number 1, reproducible tools. I'm gonna make it visible. So you should be seeing it. And it's basically just a question where I'm asking you, similarly to Ruben and Swabir that share their experiences, I just want to ask you to, so the question is basically choose one reproducible tool that you are not currently using and that you are excited about learning more and implementing in your workflow, and tell me how you're currently dealing with it, right? So I give an example here. I'm very excited about using a programming language like R. I'm currently using proprietary software SAS for my statistics. Very simple. It can be, a couple of sentences if you wish, but I just want to hear your thoughts. So it could be a reproducible tool that we talked about today. It could be maybe another one that you can come up with if you want. But I just want to know something that you're a reproducible tool you're excited about learning, implementing, and how you're currently dealing with whatever that tool will help you in the future. Once you respond to that, then your class is dismissed. So just make sure you respond to GitHub with your attendance and then answer this quiz before you leave. And once you've done both of those things, you're good to go.
Excuse me, Dr. Bastos.
Yes, Omar.
Could you please repeat where can I find the quiz? Because my internet is extremely bad here. I
So
couldn't hear.
I'm not sure how it looks like on your side, but on my side, if I go on tools, I have a quizzes option. Is that the way that it looks on your side as well? Okay, I have some people.
Is it on GitHub?
No, so
It's on ELC.
ELC, sorry, the quiz is on ELC.
Okay, let me see. Yeah, I do have tools here.
Yeah, so under tools, there's a quizzes option and it should be there.
Yes, I see it. Thank you.
Hi, Dr. Bestos.
Yes.
I have a question regarding the assignment 1. So
You're muted.
okay. Can you hear me now?
Here, yeah.
Okay, so
I cannot hear you now.
okay, sorry. I guess there's because I'm using two.
I cannot hear. You're muted.
Okay, can you hear me now?
Sorry, we'll go back to you. Yes, I can hear Shakir.
I'm so sorry. Yeah, so for the assignment, I used the function scale_color_brewer, and I used the theme minimal. But if you look at my graph, there's a white color in a white background. So you cannot actually see it in the graph, like the dot. So I'm wondering, do I need to redo the assignment or is it fine for the sake of exercise?
So I think that what's happening is that the option for scale brewer, I think it lets you you give it some values that it uses. And maybe because you did not provide those values, it didn't find a way to plot. So what I would say is, maybe just try a different one and resubmit. You can delete your previous submission and just resubmit. That will probably be better at this point. Unless, maybe if you want to play around with that, if you want to Google scale color brewer and see how you use it, you're welcome to do that if you're up to the challenge. But if not, then you can just use a different one.
Got it. Thank you.
Right, yes.
I was just gonna ask, on the website, it looked like there was a reading posted for today's date. Do we need to have that read in preparation for Thursday?
Thank you for reminding me of that. I was about to forget and about to email you all about it. Yes, so if you please go ahead and read this. It is a paper from Hadley Wickham. So he is, if you don't know who he is, he's a big person and he's a scientist at POSIT, previously called RStudio. He's the one that developed many other packages we're going to be using. So he's a very important person in this area. And he published this paper called Tidy Data, which is a concept we're going to be following throughout. And so, yeah, it's a very easy to read paper. There's a lot of tables and graphs and things, but it's going to help you to identify what is tidy data, and we're going to be using that throughout the semester. Every time I have a reading, there's a high chance I may have a quiz about that reading. So if you don't want to read it, there's nothing I can do about it, but there's going to be a quiz about it that, if you read, you're going to be able to respond to that quiz better. So yeah, please go through this and we're going to be start talking about this on Thursday. Yep.
And for the stuff we need to download from GitHub for next week's or this Thursday's class, and like I installed it and it just packages like are required to download, and it's like marked on free Excel.
Yeah.
Should we go ahead and install those too, or wait until Thursday? Maybe we can talk about it then.
Yeah, that's a good point. So on the script, there may be some packages that you have not installed before. If you want to go ahead and install now, it's probably a good idea, because if anyone has issues installing, then we can help to troubleshoot. Yeah. So yeah, thanks for that reminder. And it's Zach, right?
Yeah.
Yeah, thanks, Zach. Yeah, so if you downloaded the material from GitHub, I just want to show you quickly what that is supposed to be. So I basically uploaded a data set and a partial script. So you should have a soybeans.xlsx on your data, and then a 0 and 14 data wrangling partial RMD on your class code. So for now, if you want to just double click this RMD file, which launches on your RStudio, and look into the packages we're loading, I think you may not have read R, maybe in Janitor. I don't remember if I asked you to install those or not. But if you don't have any of those packages, you can go ahead and install. You already know how to do that using the install.packages function. And then if you have issues installing, let us know. I don't anticipate any. All right. Any other questions?
Yeah, Dr. Bestos, what did you mention about the quiz regarding the article that you shared with us? So when is the quiz for that article?
Well, that's the beauty about quizzes. You don't know.
Okay. But you'll announce it, right? When it's
It will be in class, yeah.
okay. Got it. Thank you.
Thanks, okay. All right. Any other thoughts or questions? All right, well, I'm gonna stick around till 11:10, in case somebody has a question or wants to, I don't know, share some thoughts about whatever. If you're good, if you responded to GitHub, if you completed the quiz for today, you are dismissed, and I'll see you on Thursday to do the data wrangling exercise. And so I'm gonna stop sharing and recording here, but I'll stick around a little bit longer if anyone has any questions.